Hello, everyone. Good afternoon and good evening to everyone who's listening. My name is Vishal Shah. I'm from Pitney Bowes. So today's session, basically, what I'm going to showcase is how Pitney Bowes has used Amazon SageMaker and Snowflake to create various data science solutions, something that has not only helped Pitney Bowes grow in revenue, but it also increased a lot of operational deficiencies that we had in our process. So before I go to the presentation, let me give a quick brief about Pitney Bowes. So Pitney Bowes is, so Pitney Bowes is a Fortune 500 company, a 100 plus years old company, who basically helps clients in their journey in commerce in areas of shipping and mailing. We have been in the logistics business for a long time, and I can say that we are the leaders in the logistics business. What Pitney Bowes does is, in e-commerce, they basically create various solutions related to shipping and mailing, right from devices that can print labels and print postage, to creating services where you can, when the packages get, we do fulfillment services for customers, so when packages get delivered to customers, all the back-end fulfillment has been handled by Pitney Bowes. We do all the way up to the last mile service. The last mile is handled by USPS majority of the time, but all the internal one is basically done by Pitney Bowes, right from the start to the end. I'm not going to go through this slide. Nothing special about me. I've been with Pitney Bowes for 21 years. So this is the agenda that we're going to cover today. So we're going to cover what are the different machine learning use cases. I'm going to cover one of them particularly. I'll describe a few which are very important, but there are many use cases that we do. The one that we'll be concentrating more on today's presentation would be the delivery and return prediction. We'll describe the architecture of how we did that thing, and then what were the challenges we had before we did this solution, and what was the result we got, and why did we choose Snowflake and Amazon SageMaker, and then we'll do a quick summary. So let's start with the machine learning use cases. So these are some of the use cases that we have done. One of them, which I'll be describing a little bit further in the presentation, is the early delivery and return date prediction. Very briefly, is basically what we are doing here in this use case is, we are basically, as soon as the parcel is received to Pitney Bowes facility, we can now predict when would the parcel be reaching to the customer. And because of that prediction, we can now do guaranteed delivery. So we can we can tell our vendors that we can deliver your parcel to your customer in X number of days. And then we give discount to the vendors if they take the guaranteed delivery program. Another one is a facility volume prediction. We basically get parcels. We have a lot of facilities, Pitney Bowes facilities, in which all these parcels come in. And based on the volume that comes in, we can again predict that, okay, these many parcels over a period of time are coming to this facility, and to process these parcels, I need this much of staff that needs to be there in the facility to process the parcel. Very briefly here, prior to COVID, when COVID happened, our volume in the facility increased 7-8 times, and purely because everybody started shipping online. And we had a huge influx of parcels coming into facilities where we did not have enough staff. And so our data scientist came up with a model where we can now, in advance, predict that, okay, these many parcels will be coming to these facilities based on the information that we have for the parcel. And then based on that, we actually create staff that will process that parcels in the network. Delivery and truck simulation. This is another simulation data science use case where we can tell, based on the route that a delivery truck is taking, how much time would it take for this truck to take this route and reach the destination. And if we find out that this truck route that they're following is not optimum, we can actually give them alternate routes to take so that they can reach the destination in time. And this, again, helps in our delivery guarantee that we give to our customer. Lastly is HHS classification. That's a classification. It's a global classification for products. It basically allows companies to see how much customs and duties that they have to pay on parcels. And we basically, and for doing that, we need to look at where the parcel is coming from, what is the weight, what is the size, whole lot of parameters that we have to do. And our prediction, HS classification, is nearly 90 to 95% accurate all the time. So we can basically tell when we are shipping the parcel out. And this is basically for international parcel, we're shipping it out. This is the custom duties that you would have to pay on this. And then based on that, they can approve the vendor can accordingly price their parcel to their customers. So now I'm going to go more in the package delivery and return prediction use case. So what this use case was, is as I told you earlier, is basically we wanted to get the delivery date or a return date prediction as soon as a parcel has reached our facility. And we can give them a number saying that it will take X number of days to reach the destination. The vendor can then give guaranteed SLAs on their future sales to their customers. So we take historical trends, and then based on that, we say that based on what we have been seeing, this is the estimated date this parcel will take to reach this destination. And for that, we take all kinds of different kind of data, like we have the package data, we have the network data, we have the truck data, we have the facility volume data. We take all this data and combine it to create that estimated prediction. Now, when I talk of estimated prediction, we also have to look at what are the different times in which we need to make sure the prediction is accurate, because a parcel goes through multiple stages. It goes from induction, which is when the parcel comes to the facility, then it goes in transit when it goes from facility A to facility B to C, and then if a parcel is handled by USPS, then the last mile of USPS information, so that data needs to come in. And then finally, the delivery, like has it delivered to the customer or not. So based on those predictions, we need to give accuracy percentages. And if you see on the board, we are giving nearly 90% accuracy for all steps. So for this particular use case, the goals were that we wanted to get the prediction as soon as we got the parcel, so that we don't have to wait till a parcel gets sent out. And then it should get a prediction in multiple steps. And then it should be accurate, nearly 95% accurate. And then it should be on a single day prediction. It should not be across multiple days, because then we'll not be able to give delivery guarantee. And then lastly, it should basically do prediction on all tracking services. I just take my mask out. So what were the challenges that we had in the solution? One was that all the data that we needed was not in one place. It was in the truck data used to come from a different system, the facility data used to come from a different system, the parcel data, the USPS data, so all the different kind of data used to come from different systems. And when our data scientists had to work on this, they had to ask the data engineers, okay, give me the data from here, give me the data from there. And then a lot of times we don't get data on time. So again, when they do those predictions, because it's not live data, they are not able to, even though they're giving a prediction number, it's not always accurate because the data is stale. It's not live. And then plus, initially, the data scientists used to create these models, deploy it, train the model and deploy it all manually, because we did not have a solution which was doing anything in an automated fashion. So the data engineers will give them all the data, put it into S3. Then the data science will write a Jupyter notebook, take that data, prepare the data, train the model, deploy it, give the output, again back to the engineer. The engineer will take that data, put it into our database. Then the BI person will take that data and create a visualization dashboard. So the turnaround time for doing all that work was lots of days. All right? And that's where we decided to go with Amazon, SageMaker, and Snowflake. So what that allowed us to do is, A, it allowed us to centralize all our data in one place, which is Snowflake. And B, with SageMaker, we were able to do continuous model deployment, training, and preparing of the data in a continuous manner. So if I go to Snowflake, let's look at Snowflake. Why Snowflake did we choose Snowflake? So Snowflake, as a lot of you probably must have known, it's a cloud data warehouse. It's basically the three big feature set of Snowflake Cloud Data Warehouse is it's cost effective on scale. So basically, one is it allows you to, you only have to pay of what you use. So it's a pay as you go model, which is like for any cloud native application should be able to do. But the other part is that you can scale, and you can scale as much as you want because everything is in S3 or it's Amazon. So you can scale up and down as much as you want. Performance-wise, we have evaluated Snowflake with at least 3 other data warehouses. And we found that the performance in Snowflake, as far as management, as far as the usability, and as far as ease of use, is nowhere near the other two. I'm not going to name the other two, not able to, but it's one of the best. And it makes, because it's a model in which you can combine multiple data together and then basically still control the cost. Like whoever is using it, they'll be paying for that. Outside of that, it's just a storage cost, which any database would use. It's very cost effective. And then lastly, you can connect Snowflake to a whole lot of different integration. So Snowflake has integration to a lot of ETL tools, a lot of BI tools, a lot of data science tools. So because it is extensible, you can basically create a lot of data science use case with it. Because data is residing in Snowflake, we pick up the data from there and directly use it within the data science use case. Why SageMaker? SageMaker makes, as I told you earlier, that if people wanted to create that delivery guarantee, they have to go through all these steps of getting the data, creating the model, training the model, and then deploying it. And then people can use it. And then if the data changes, the process will redo the whole process again. What SageMaker allowed us to do is it abstracted this whole process. It allowed to do all of this process in an automated fashion. So now data is retrieved using Amazon SageMaker pipeline directly from Snowflake in real time. Data is prepared, models are trained, and then models are deployed. And then there are features and rules which are set up whereby if the data changes, it will retrain the model again and redeploy it without any human intervention. And we have a fully automated system which we have created. And the main piece which SageMaker also helped was we actually created a pattern of this model deployment. So now any data scientist, if they want to deploy and train the model automatically, they can use the same exact pattern with the same infrastructure, and then they can deploy the model. So the amount of time, turnaround time it takes for a data science to create a new model, train and deploy, is in days, is in less than a few days than lots of days. So you can basically say, and once it's deployed, the retraining is completely automated. They don't have to do anything. They just have to put in the new model artifact, and the SageMaker will automatically redeploy and redeploy the code. Again, SageMaker, as you guys already know about, is basically, a lot of people confuse SageMaker as an AWS service. It's actually not a service. It's a platform of a lot of things done together. So that's one misconception. Everything in AWS is a service. This actually is not just a service. Even though it can be called a service, but it has a lot of things combined together in one, where it can, there's things that you can use to, as a user interface, where you can have SageMaker Studio or an AWS console. There is a machine interface through which you can basically deploy different kinds of rules or in machine learning infrastructure like SDKs, APIs. And then, of course, there's infrastructure component to SageMaker where there are different containers that can spin up based on when SageMaker deploys it. So that's SageMaker. So coming back to our to my data prediction workflow. So we have two different prediction workflows. One is the real-time workflow, and one is the batch workflow. What the real-time workflow is at any given point of time, I can send in data to the endpoint, and what that data will do is it will basically in that data I have to pass in some parameters, and those parameters will basically based on the parameters, it will basically invoke a Lambda service. The Lambda will invoke the SageMaker endpoint, which will know that this is the model that needs to be executed to fetch the data. So in real time, I'm actually providing a 2-day delivery prediction saying that if the parcel is going to be, if the parcel is coming to our induction on this date, then it will get delivered to this location in this date, in this many number of days. So not only that, it'll also say that if the parcel is following point A to point B, and then point B to point C, we can say it'll go to point A at this many number of days, point B at this many number of days, and finally delivered at this place in this many number of days. So I can give prediction even at individual steps. And this is happening real time on the real-time flow. The advantage of doing this is if data science has to update their model, the row flow will not change. They will deploy the new model they will basically create the new model and they will put it into S3. The SageMaker, the Lambda service will know that there's a new model artifact in there. It will invoke SageMaker. SageMaker will take that new model, look at the new data, train the model, deploy it, and now the live prediction flow will now use the new model. So there is no, if you realize, for the data scientists, they can work independently without worrying about the whole infrastructure of the workflow which is being invoking them. Whereas the real-time model does not need to know, is the data ready for him, because it's all happening behind the scene. So that's the real-time prediction flow. This is the batch one. So in the batch one, basically what's happening is we are pulling the data from Snowflake, putting it into an S3 bucket, and then the Lambda service is getting invoked, which will again call the SageMaker's endpoint with the data, produce the output, and send it back into Snowflake itself. So what has happened is here we are basically, this is basically used for real-time operational reporting. So we take the data, put it into a Snowflake database, the curated data into the database, and then Power BI is basically taking that data and visualizing it also real time. So we have a direct connection with Snowflake table. So anytime a person goes to the Power BI dashboard, it will show them the latest update of the data coming into the database. So that's the batch prediction flow. The other thing in this particular diagram, the batch one, I want to mention, I'm actually going to go back one slide. In the real-time prediction flow, if you notice, the top portion where, as I told you, the data science is putting in the model artifact into the repository. And then we also use a couple of CI/CD tools outside of SageMaker for basically putting that model artifact into the SageMaker environment. And for that, we are using Jenkins. So Jenkins basically, because all our model artifacts are actually stored in Git, and Jenkins takes the data from Git and gives it to SageMaker automatically, and then SageMaker performs the automated CI/CD of training, deploying the models. And the reason why we did this, the people will ask, like, why did you put in an additional CI/CD process when you already had SageMaker pipeline doing all the work? The reason was that, A, we wanted to make sure that all the model artifacts are stored in Git, so we have a version control system, so we can know that which are the models, if people change a model, we know who changed it, when did they change. And plus, we have a full history of all the different kinds of models which are there. Plus, it's a central location of all the models, so that tomorrow some other data scientist wants to deploy, take one of that existing model and add it to his or her own model, then they can directly connect with Git, get the same model, and then deploy it in the SageMaker code. The other thing is, we also allow developers. So the data scientist is one party to this workflow. The other one is the developer. The developer themselves can also put in model artifacts for operational reporting. So they can also do the same thing. They can put in the model artifact, and Jenkins will take that and deploy it into the SageMaker environment. So the other part is in the batch prediction workflow, the only human piece in the batch prediction workflow is the person who has to be responsible of getting the data from Snowflake. And the reason why that is a manual task is because the batch was made so that we can give different kind of data scenarios to the models. So that, because remember, the model is only effective if it can see different kinds of data, so that it can create different kinds of feature set on top of the data. And feature set is basically a layer from the raw metadata, which is basically enriched so that people can understand the data well. So, and if you want to basically have a good model, you want to make sure that you pass in as much different kind of data as possible. Because then all the noise in the data, where sometimes the data can have, like say you have null in the data, or sometimes you're expecting the data to have X number of information, but someday it may not get it. So you want to prevent all those errors in the data, and for that, you want to create different kind of features, which will allow you to basically say that if this data comes in this fashion, use this feature and take this model and deploy it. So that's why it's important for us when you're doing the initial testing to pass in all this data, different kinds of data, and that's where the human person will come in. That's the only time a person is actually involved doing all this model training. So going back, this is our architecture for, not architecture, but this is our machine learning process, where we can get data from using AWS Lambda. So we have a lot of our IoT data which comes through AWS Lambda into S3, and then the model is done based on that. We have data coming from Amazon Kinesis. Again, IoT data coming from our devices that we have at a customer site. We have curated data coming from Snowflake, as I told you, batch data that we bring in from Snowflake. We get that data. We get data from flat files. So there could be, USPS sends us tracking data in files in an FTP server. So we can get that flat file data. And then we can get data in Amazon S3 from various sources. For building the model, yes, we are using Amazon SageMaker as our main model system. We also use Amazon EMR. So a lot of times what has happened is with lot of IoT data, which is coming into S3, the raw IoT data in its form may not be ideal for that use case. We might want to curate the data. Now, there are two ways to do the curation. You load it into a database and do the curation, or you use some Amazon EMR, where it will churn all the data together and create a curated model. So we do have Amazon EMR doing certain kind of work. We use GitLab, as I told you, to get our model artifacts and other objects. And then Jenkins for doing the CI/CD process on the model. And then finally, once we have the data, we basically use Tableau and Power BI to visualize the data. Now, if you look at this, I am assuming majority of the companies are following similar kind of architecture, which is getting the data, building the model, and then deploying and visualizing the data. So, but the way we have done this is, for us, this model, we have made sure that it's a repeated model. It's not like every time we have to create this. We have created a full-blown pattern infrastructure where any new model that we have to create, I can bring up this model in days, like in a couple of days or 2 to 3 days. I can set up the whole model, set up all the automation, do all the QA on it, and then we can get it deployed. So if you're able to do that quickly, that's where you're going to get the benefit. Because now you can start thinking of use cases where you say, okay, if I can get this data quickly, I can do this business. You can do that now with that model training program. And machine learning is something which is, it's a science, right? It's like not, like anybody will not be able to do machine learning. You have to understand what machine learning is and what it does behind the scene. And SageMaker and Snowflake for us have been the two products that has really, really helped PB grow in this area. This is a sample report which shows the model accuracy and how many delivery percentage that we did. So if you look here, what is so special about this? So here it's showing that all the models that we have created, they are 91.6% accurate. Of course, our goal was 95, but post-COVID, because of the sheer volume of data that we receive and sheer difference of data that we are receiving, there are a lot of noises in the data. And we are always working on eliminating that noises so that the models can get more better predictions on top of it. So this was, I would say this is not as of the latest. This is a few months back. It's 91.6%. And then if you look at it, it's 6.3% delivered before the estimated delivery date. Now just imagine, we are giving a prediction that it will get delivered X number of days from now. Most of the parcels are actually getting delivered even before that. So our prediction is way better than what actually it is happening. So that's where we are getting the benefit, because when we give guaranteed SLA commitment to our vendors, we are always fulfilling our commitments. So we never have to basically go back and say that, okay, we did not fulfill our obligation. There are cases where some of the delivery prediction numbers, some of the parcels don't get delivered on date. And what are those use cases? Those use cases are, one of them happened when during COVID, one of our big facilities was closed down, was locked down. And because of that, all the parcels were rerouted to a West Coast facility. Now, imagine a parcel coming in East Coast, goes to the West Coast, and then from there it has to go back to somewhere else. The time it will take for the parcel to reach the destination is not going to be what we would normally estimate. So there, our data scientists have to go back and basically retrain the model, assuming that the route of this packages will now go, instead of coming from East Coast and going out, it'll be from West Coast and going out. So that allowed it to, we did that. So this was a number, because of the COVID, when we had that facility go down, and that's why it's showing 2%. Otherwise, normally we are always on time. What else? Okay, so summary of this. The summary basically is we basically make data accessible to data scientists and data analysts. They get structured, because Snowflake allows us to load structured and unstructured data. So a lot of our IoT data is unstructured, and a lot of our transactional data is structured. So Snowflake can ingest both of them, and we are able to use both of them. We also use event-based data as a tool for IoTs, which comes out of S3. And then for training models and deploying it, we use Amazon SageMaker, Git, and Jenkins for automation. So that's it on my presentation. And this is lastly what I want to know, what we are working on now. We are exploring this new feature of Snowflake called Snowpark. And Snowpark, basically, what it does is it allows the data scientists to work within the Snowflake environment, very close to the data, and do all that processing. So the scenario is like, earlier we used to take the data from Snowflake out into SageMaker, have SageMaker do all the work, send it back into Snowflake, and visualize it on top of it, or send it back to an API, real-time API call, and have them do it. What Snowpark is going to allow us to do is, it's going to basically, because it's within Snowflake, it can now reach the data without any problem. It's in the same environment. It can perform all the processing of that data, modeling and curation, and then can send the data back in Snowflake. So we are basically working in a single environment. So that makes, a whole new opportunities where we can now connect different kinds of data without any issues. We don't need to involve a data engineer. Just give access to the different kinds of databases in Snowflake. People can join everything and can work on it within Snowflake environment. So that is something which we are actively working on to move a lot of our workloads to using Snowpark. And I recommend everyone that they should try Snowpark. And again, because it's completely managed by Snowflake, it makes all the, they constantly are working on optimizing all the background processing and all those things. And it's completely Snowflake managed. And it also, because it's in Snowflake, we now have access to different kind of other features which are also part of Snowflake, like procedures, streams, tasks. These are features which Snowflake has, which can now be directly accessible from the Snowpark environment, which in SageMaker case would not be possible, because you would have to actually do it in Snowflake, bring the data, then work with SageMaker. So that's it. Guys have any questions for me? Yeah, go ahead. Yeah. Yes, to the vendors, to our vendors, yeah. Yes, that's correct. Absolutely. And the vendors are then able to give the same kind of guarantee to their customers when they're shopping on the site or when they are basically buying from them. So they can only give that guarantee if we are able to fulfill our guarantee. So, yeah. We also, just to add to that, we also give, there are companies, like in one of our other business lines of business, we actually incorporate this prediction at the sale level. So when somebody is going and shopping on their website, there itself, it will like how Amazon gives, where you can give next day delivery, 2-day delivery. Those information is coming directly from our API, and they can pop up on the screen, and they can select it from there. So the customer can, so for the end customer, they don't know it's coming from Pitney Bowes prediction API, but it's actually happening in that fashion. So one of our lines of business is actually doing that. Any other questions? Yeah, go ahead. IoT. Yeah, so it's a good question. So basically, when we get the trucking data, all right, the trucking data comes with, so there is a portion of weather information in that because going through a GPS location. So there's a portion of the weather information coming as part of the data, not everything. But yes, if we get the data, it would make a difference. That if the weather is not good, of course, the truck is not able to travel that place, and it's going to affect the eventual delivery of it. But again, those are pieces that we would have to make it as a part of the model, like that these are what do you call it, exceptions that we can either make it as a part of a model, saying that if these exceptions are there, then ignore that or do certain things with it, basically. But yeah, that's an exception. That is not regular. Like, weather is not going to be bad every time. So we cannot say that, put that in the model, saying that to predict it, always predict the weather is not good. So anybody else? Anything else? Yeah. Yeah, hi. Yep. Uh-huh. Yeah. Hmm. No, so the real-time data is coming from the application. But an application may be going to Snowflake to get the data. That's yes. Oh, so yeah, so the application is basically querying. So our the backend to the application is Snowflake, all right. And so we have APIs. We have integration to fetch the data from Snowflake. The API it will fetch the data from Snowflake and send it to the model, like as an endpoint. Yeah, absolutely, absolutely, absolutely. Yeah, sure. Sorry, the light is directly coming. That's why I'm putting my hand. Anybody else? Yeah, go ahead. Sorry, I'm going to come. I'm going to come there. It's very hard to hear. Go ahead.
Trying to ask, how is billing done? You're actually moving data between SageMaker and Snowflake. When and where processing is done, and how you're actually setting up cost structures around it.
So for us, it's everything with it's a single PB account. So for us, all that cost is borne by a single parent account. But if you had, say, a customer-facing application where you wanted to separate out, you could create your own warehouse for that customer. So you could create multiple, because creating a warehouse does not cost you anything. It's only when you use it, you get the cost. So you could make a customer-specific warehouse, and then for that process, call that warehouse for Snowflake. So then you'll know that for this was the cost, basically. We have done that for a lot. Yes, for this, we have done that for a lot of our business units. For a lot of our business units, we have created their own warehouse for it at an individual business unit level. So now, if a data scientist from that unit is using this environment and using their own Snowflake account, we don't have, every unit don't have to pay for it. And in big companies, every business unit has their own cost center. So we actually set up a warehouse with a cost center, and then it automatically gets charged. Our IT stay handling all the cross-charging of that money. Okay. Yeah. We use Lambda, we use Snowpipe. If it's a real-time streaming data, we use Lambda and Snowpipe. If it is batch data, it comes, like we use various tools, like we have ETL tools, we have real-time replication tools, like we use SnapLogic, we use HVR to put real-time, so HVR is basically used for our log-based data. So from SQL Server, Oracle, SAP, we get all that data put into Snowflake real-time, all right? As soon as change happens, comes here. For the other smaller data, we use batch using ETL tools. And then the IoT streaming data, which uses AWS IoT, it comes through Kinesis and Lambda into S3, and then it invokes an SNS in putting the data into Snowflake. Yeah, good. Yeah. So when it's a log, I'm talking large volume data. Yeah, so that's what we're using HVR, which is called which is from Fivetran now. I would not say HVR, Fivetran, because they have taken over HVR. So there we use change CDC data from those databases into Snowflake, and we have a rich integrate. Like we have done that for Mongo, SQL, Oracle, MySQL, SQL Server, all of those into Snowflake directly, and that's streaming live CDC data into it. No. The real time is the application already has fetched the data to be sent out real time. So, of course, technically it can still be part of the real time call. Say somebody on the web, as I told you in our other application, in the sales screen, the output that's coming out is as soon as they say checkout, it makes a call to our production API with the data, with that information, and sends back the estimated delivery. This is the time it'll take for you to deliver, and that shows up on the screen. But behind the scene, that information about that customer, it is coming from that application, but there could be some data which is also coming from Snowflake, some lookup data which we need as part of that API call, which might come from Snowflake at the same time, send in an API call and send it back. That whole turnaround time is I would say less than 1 minute. So. No, we are doing both. We are putting the data in S3 and then Lambda invoking the SageMaker endpoint and then sending the data. We also do directly connection to Snowflake because you in SageMaker Studio, which is their console, you can set up your model which can connect to Snowflake. That's another integration. So integration with SageMaker going directly into Snowflake and getting the data. That's one of the critical aspects. So depending on the size of the data, like if you want to transfer a lot of data, you don't want to do it on the live wire because it'll take a time to get it. If you want to do it, depending on what flow if you're using a batch flow, you have a choice, right? You can put it in S3 and do it, or you put it in SageMaker. Now the other problem with S3 is if you put it in S3 and suppose our the data is residing, Snowflake is residing in a different region and S3 is in a different region, and SageMaker is deployed in a different region, then you get region transfer cost, data cost. That time it is easier to make a call directly into Snowflake because then it's a JDBC call to the Snowflake API. So if there are no further questions, I will conclude this. And I'll be available here for the next, for some time. So if anybody has any questions after, please feel free to reach out to me. Thank you very much, guys.